Hi students, so welcome to Physics with ER. Discuss regarding the concept of different types of satellites. Satellites, so which we can be classified into two types, geostationary satellites and polar satellites. In detail about this which we are going to discuss. So these geostationary satellites are the time period of satellite in a circular orbit around the Earth must be equals to rotational period of Earth. So we know rotational period of Earth which you have been taken for 1 day, so which is nothing but 24 hours. So this is a example which we can see it as a geostationary satellite. So this will be the ground station which we are using, and then this is the one which you can call it as a geostationary satellite. So this figure which it will represents that. So this geostationary satellite, so which revolves around the Earth, so around a radius approximately equals to 36,000 kilometers. So the orbit of geostationary satellite is also known as geosynchronous orbit, because how Earth is rotating itself, geostationary satellites also it will rotate in the same manner. The direction of rotation of geostationary satellite is from west to east. So the height of a geostationary satellite above the equatorial plane, so around the value is 35,800 kilometers. So what are the uses of this geostationary satellites? So these are used to determine the shape and size of the Earth. These are used to study the upper region of the atmosphere. So these are used as a communication satellite to send the message to distant places and to telecast the TV programs, which is nothing but television programs. These are used to detect the mines and minerals in the Earth. So then if you are coming for another one which you can call it as polar satellites. The satellites which go around the poles of the Earth in north-south direction are known as polar satellites, whereas geostationary satellites it will revolve from west to east, whereas polar satellites which it can rotate from so in direction of north-south direction, so which we can see here. The orbit in which this satellite moves is known as polar orbits. The time period of a polar satellite is about 100 minutes. So for one complete rotation, how much time it is going to take means it is going to take around 100 minutes. So the height of polar satellites from the surface of the Earth is around 502, so 800 kilometers. The angle between the equatorial plane and the orbital plane of polar satellites which have been taken, so it is nothing but 90 degrees. So in the name itself they have been given it as these which are nothing but polar satellites. So depending upon that how much angle you have been taken, it will be of 90 degrees. So you have to see how the polar satellites means. This is the diagram, so which we can see that which revolves in north-south direction, so which we can take it. So this is a combination of both polar orbits. Here you can see this is a polar orbits, and these are the one which you can take it as a geostationary orbit, so which we can take it. So uses of polar satellites: for groundwater survey, for preparing wasteland maps, for identify the source of pollution, how much pollution is there. So sometimes which you can see that in some places like Delhi, so pollution is more, how they can set that means, so with the help of these polar satellites. For detecting the potential fishing zones, to locate the position and movements of troops of enemies. So in some countries which have been taken, which they will survey, so whether any of them they are coming entering into their country, so based on that, for that purpose also we can use this polar satellites. To locate the place and time for any nuclear explosion, so whenever wars or something it has been happened, under that condition these polar satellites, so which it can be helpful. Students, please pause the video and then write the answer. So before going to do that, please like the video, subscribe my channel and press the bell icon to receive the notifications. So a geostationary satellite is, so what is the answer? So which you have been seen, revolves around the equatorial plane. So what you have been said, so regarding that one. So further one, a polar satellite. So answer which you have been seen, so which is nothing but revolves around the polar axis. So the further concept is, which you can call it as weightlessness. Regarding this weightlessness, which you have been seen, weight of an object is a force with which Earth attracts. In case of satellites around the Earth, every part of the satellite has acceleration towards the center of the Earth. So whenever force of attraction between them is there, so that gravitational force F is equals to capital G into capital M into small m by r square, where small r is equals to r plus h, where r is the radius of the Earth from center and h is the height above the surface. So whenever an object is rotating, so that it will require some necessary centripetal force. The gravitational force of Earth provides a centripetal force to the satellite to move in its orbit around the Earth. So this also you have been already seen, F is equals to mv square by r. So in this position, this satellite and any inside it are in state of free fall. So that means gravitational force which is equals to the centripetal force. So whenever you have been taken this, so weight W is equals to, so centripetal force minus gravitational force which you have been done, we are going to get that as weightlessness. So that weightlessness is nothing but, in the name itself they have been given, so W is equals to 0. Why? Because here gravitational force you have been taken which is equals to centripetal force. So under that condition, so weight of the body, so which you have been taken, we are going to get it as W is equals to 0. Satellite and anything inside it are in state of weightlessness because they are falling freely. The same statement, so which you have been said. In a satellite around the earth, every part and parcel of the satellite has an acceleration towards the center of the earth, which is exactly the value of earth's acceleration due to gravity at that position. So that we can call it as free fall. So people inside manned satellite experience no gravity. So this is a one important point. So here this gravity defines the vertical direction for us, that there is no horizontal or vertical directions for them, all directions are same. So pictures of astronauts floating in a satellite shows this phase. Students, please pause the video and write the answer in comment. In a satellite around the earth, every part and parcel of the satellite has an acceleration towards the center of the earth. Students, please subscribe my channel, like it, and then share to your friends, and then don't forget to press the bell icon to receive the notifications. So thank you. Have a nice day.